on trig, right? So we did a bunch of trig ones. We did this as a kind of a proof, right? And I got to the point where Emma finally agreed that, and Gould finally agreed that it's not just because I say so, it's because the guy who did 1,000 different, trial runs before he finally found the one that worked said so, right? So yeah, whoever it may have been and did this proof. So instead of us sitting here and going through another one of those, I'm just going to give you the next one. Okay. And so were you to go about all of this jazz for cosecant, you would wind up with negative natural log, the absolute of cosecant of x plus cotangent of x plus c.
Secant of x plus tan of x over secant of x plus tan of x. What was that for?
Oh, what got multiplied by?
Yes.
Oh, I see what you're saying. Yeah, for this one it was cosecant of x plus cotangent of x. Yeah. So if you did that problem using that, that's what you would get to. Okay. But we're gonna bypass it. You're just gonna have to believe me for that one. Fair enough? All right. Guys, what's the deal with these, right? Could and will the AP exam ask you to find these integrals? Yeah, right? So what is my suggestion? These are going to be 4 that we're going to want to memorize, right? Yeah. So before break, guys, one of the things I'm going to be giving you guys is a list of all of the things that you are going to want to have memorized, right? Now, we've already started with the stuff from this list, right? Which is a list of stuff that you really should have memorized from pre-calc, right? These are all pre-calc concepts and trig identities and things like that. But then we have all the ones from calculus as well, right? So there's a bunch, and we'll keep. I'm not going to make you memorize anything for for our exam. I will give you some things as resources for that. Okay, where was I? Here. Okay. We're not finished. We're probably going to wind up having to move that back a day. We'll see, because we're going to need at least all of today and Thursday to get through the rest of this. It's probably going to have to move back a day. Probably not Gould. I don't know. Yes. Yep. It'll definitely be a test day. All right, guys. Example 11. So now we should be able to handle a problem like this. All right. So if we look at this type of a problem, give me something that we can do. Move the 5. I would agree. Let's get the 5 out of there. All right. So that gives us this. Since it's a U sub problem, what are you thinking? What are you thinking, guys? Your gut. You want to go with x cubed plus 1. All right. Brandon wants to go with x cubed plus 1. Very good, B. Now what? Derivative of that, okay? I get that, right? Keep going, B. You're gonna walk me right through this. Now what? You want to move the 3 over because you want it to match x squared dx. Okay. All right, so Brandon was trying to get this to match with that. And has he done so? He has. All right, now what, B? Okay, go ahead. So Brandon says 5 over 3. I got to put an integral sign, right? And then you said tan of u du. Like that? Questions, Phil? Brandon, so far so good. I agree. All right. So far so good. I agree. And well, we just spent some time deriving some integrals for tangent, right? And what is our integral for tangent? Negative natural log of cosine u, right? In absolute value, right? In absolute value, okay. So I have 5/3 negative natural log of this plus c. And then last step B, plug the u back in. Looks like this guy, right? You like that? Yeah, Brandon, you got a good handle of that. You did a nice job. All right. Again, what was he doing here, guys? Saw the constant, identified his u, took his derivative, made the substitution, right? Took his integral, put the u back, right? That's our process, right? That's our process. All right, what do we got for B? I want somebody to walk me right through it. I kind of like that. That was fun. Who wants to walk me through it? Come on, don't be a wimp. Oh, you guys are wimps. I got to walk through it.
It's true. that is your job.
Awesome, Lexi. Give me something to do, Lexi. Pull out the 2? I agree. Wow, she really took care of me. One false swoop. Okay, what do you guys think here for the U? What do you think for the U? You want to go with e to the negative x? That seems reasonable. Yeah, I'm just looking at which problem I did. Why? Wait, mine doesn't look. Hang on a minute. What number? Which example is this? Oh, I'm looking at the wrong. Hang on. Hang on a minute. I just confused myself where I was. Example 11, 10, 11. Well, where the heck did I put that? Oh, that was 8. Oh, I see it. Okay. All right, no problem. All right, what do you want to do? So you guys think it's the e to the x? Okay, we'll go with that. Derivative of that. It's a chain rule, right? Because the exponent is differentiable, right? What's the derivative of the exponent? -1, right? So isn't it just -1 times e to the negative x for my derivative? All right, that's good news, right? Because if I now just divide by -1, all right, sweet. So that is this piece and this piece, right? So we can go ahead and rewrite this as -2. Why -2? Because I multiplied the -1 on the other side, right? Secant of u du. And luckily for that old man from years and years ago, we have that as -2 natural log of secant x plus tan of x plus c. Oh, not x, sorry, wrong letter. What should I use? And last step, go ahead and plug that e to the negative x back in, right? Boom. There you have it. All right, so thinking about u substitution. So far, what do we have? Well, we have a few of these that we have to kind of memorize, correct? Okay, great. Now we got to get into what I'm going to just call a whole bunch of random cases, okay? What are we going to do in all of the scenarios that are going to come up, guys? And we got like 7 pages of scenarios, okay, to go through. All the different types of things that could happen as we progress through these problems, okay? So if we look at number 12, 12A, I got 5 different things that we want to look at today on each of these. I just got to find my page 12. There it is. Okay, so talk to me about what you would consider your best scenario for you and why. Because now you got a 50-50 shot. Is it going to be the top or is it going to be the bottom of this? Which one do you want to call you and why? I'd say the bottom. Why? When you take the derivative of something squared, you're going to get something to the first degree, right? So I agree. I would suggest that this is the best way to do it. Derivative of this is 2x dx. But we don't want 2, right? So I got to get rid of that 2. And there's my substitution. So there's my x dx, and there is my u, right? So this is actually just the integral of, actually a half of the integral. Why do I got a half of one now? Yeah, because we got this half du, right? So it's going to be an integral of 1 over u du. What's the rule for the integral of 1 over u? This is from our chart, guys. 1 over u. So it's the second page. It's the natural log of the absolute u, right? Yeah. So this is a half of the natural log absolute u plus c. And there is our first case. Nothing all that crazy about that one, is there? Right? Pretty straightforward. How about here? How about B? How about B? This is kind of a hidden one, a little bit. Again, remember, you're looking for something that when you take a derivative, it gives you something that you can what? Substitute out of what we have in front of us, right? So thoughts. And we could try things, but that would take us time, right? All right, so Austin's like, well, let's get this 5 out of here. Sure. Makes it a little bit nicer to look at. Anybody think they know it? You're gonna be mad when I say it. Is it just x? Well, what's the derivative of x? 1. Right? You want to use natural log of x because what's the derivative of natural log of x? 1 over x. So the 1 over x, right? And it becomes 1 over u then, right? So my u is going to be my natural log because du is 1 over x dx. And there's my 1 over x dx. And here's my u, right? So what is this going to look like? It's going to be 5 integrals of 1 over u du. And it's the exact same problem that we just did, isn't it? So it's 5 natural logs of this. And there's our solution. Pretty cool, right? I think these are cool. And this is the math geek in me. They're cool because I think they're kind of puzzles in a little bit of us in that sense, which makes them a little interesting. Maybe they're cool to do now. They're maybe not quite as fun to do at 11 o'clock at night when you know it's due, but you get the idea. What do you want to do here? Let's make it look a little nicer. Let's make it look a little bit nicer. Give me something I can do right off the bat.
Turn the power.
Okay, fool around with the power a little bit. Good. What else? How about the 4? Yeah, or I could move the 4 out in front. All right. I think based on our previous experience, what seems like a pretty good choice for you? Natural log, because then I'll get a 1 over x and I'll be able to get rid of that, right? All right, so my 1 over x dx, right? I didn't put the 1 there, but you get it. And my u, right? There's my u. So we write this as 1/4 of u. Cool. All right. A little bit of practice on this one, guys. What's my integral of u to the 2/3? Add 3/3 to the 2/3, right? What do you got? You got 5/3. What's my corrector in front need to be then? 3/5. All right, so what is that going to give me? That's going to give me 3/20 of what? The cubed root of u to the 5th power? So the cubed root of natural log of x to the 5th power plus c. Evan's digging these. He is just digging these. Huh? Am I sure he's digging it? Oh, I'm sure he's digging it. Because if he's not, he's a dork. He's not a true AP math geek like me. And I can see his inner math geek right now. All right, we see again, right? We see again here, guys. We have a natural log. We have an x in the bottom. Natural log is going to be a good choice again, right? So I'm going to take out this. Should I brace for impact? All right, so I have 1 over e cosecant of u du. And again, just to make sure you guys all see it, right? Here's my 1 over x with the dx, right? Wait, hang on a minute.
Wait, where did that come from?
Hang on a minute. Sorry, guys. Sorry. Is that better? Cool, can you get that door? Thanks. That door distracted me. The noise was already distracting me. You guys okay with what I just did? I fixed it, okay? So yeah, the derivative of this is clearly 1 over x dx. There's my substitution for du, and here's my u. Better? So this brings into consideration what we did in the last special case, right? So now we have 1 over e, and this is one of the ones that we just got to know, right? And so that's going to be times negative natural log of cosecant u plus cotangent of u plus c. And then I can go ahead and plug my u's back in, right? So this is, again, if you got to make a note of it, guys, right? This is, there it is. Right? Is that what it is? Oh.
I don't know if it bounces off the wall.
What's that have to do with English? Well, he's not in there right now, though. Seriously.
They're coming back from lunch.
Not bad.
All right, guys, is that cool? Are we all right with that? All right, what do we got? We got one more of these to do, right? We got to do the where is it? I didn't do this one for some reason ahead of time. Did I? 12. There it is. Okay. All right, gonna rewrite it. Right. Again, guys, you're gonna see both formats. You're gonna see the phrase arctan used. We just have to remember that that's the same as one of these. All right, you guys agree with that? All right, we gotta understand that we gotta convert that to that. Guys, this is one of the. This would be like one of those problems that you just gotta sort of see it, okay? And this goes back to how well did you really memorize some of the things that you have to memorize? One of them being the following, okay? If we go back to our derivatives unit, one of the ones was taking the derivative of the inverse functions. Arctan being one of them, right? Well, the derivative of this required us to use a special case, which is that. So the derivative of arctan is 1 over 1 plus x squared. So if I want to integrate tangent of x over 1 plus x squared, what am I going to make my u? Oh, no, the other way around. Because I want the derivative to match what's here, right? Yeah. So I'm going to make my u tan inverse of x, which means that the derivative of that is 1 over 1 plus x squared dx. So there's my what? There's my 1 over this dx. There's my du substitution. My u is just that, right? So all this would be is the integral of u du, which is a half of u squared plus c, or in this case, that. Right? But guys, again, do we all understand that there's really not a great way to do that problem unless we know that derivative, right? And these are the cases that we're going to run into, okay? The roadblocks that could happen. Yeah. You know, it's funny that you should say that because when I was doing this problem, I was wondering the same thing. I guess the question is tan inverse times tan inverse equal to tan?
I thought it wasn't like an actual exponent, it was
That's
just
what I
there
was
to
thinking.
represent that it's an inverse.
That is a symbol.
Right, but then it still is tan inverse times tan inverse, right?
Yeah.
So, well, okay, so I guess if you really want to answer the question, Brandon, you agree that tangent of 45 degrees gives us what? 1, good. So that means that, tan inverse of 1 should give us, okay, but what mode am I in? Radians. So 45 would be the same as what? Pi divided by 4? And pi divided by 4 is that. So it worked, okay? So now the question is, what is tan inverse of 1 times tan inverse of 1? So can I take this and square it, and I get that. So now if the model remains the same, it would be, or no, it wouldn't. It's just, no, you can't do that.
It's just
Yeah, it's just symbolic. Yep. Yep. All right, guys. So here, what do we have? We have our first case of a definite integral that's going to require us to use u substitution, right? Definite integral because I have what now? Zeros and 1 on top, right? So if you run into this case, right, what could Evan do? Well, if Evan was sitting at his exam, he could write this down 3 times, multiply it all out, then take the x, distribute that, get something that's in terms of degree now, right? And then integrate that. And that would be great. That's going to take time. What is a precious commodity when you're taking the test? Time, right? So to me, the better way to do the problem is to recognize that, okay, well, there's an x squared in the problem. What's the derivative of something with an x squared? Something with an x, which is what I want, right? So I think that x squared plus 1 is going to be my u. And so a half of du will give me an x dx. There's my x, there's my dx, right? So now I can rewrite this as a half of u cubed du. Everybody agree with that? So I have a half of that, which is the same as, bless you, which is the same as that, right? Or that. Okay, I'm pretty good with all those. I ran through that pretty quickly, but I'm hoping that you're sort of catching on with what's going down here. Okay, plug in my 1. Plug in my 1. I get 1 squared, which is 1. 1 plus 2. 1 is 2. 2 times 2 is 4. So 2 to the 4th is 16. Then, right? Because it's doing that twice, right? An eighth of 16 is good. An eighth of 16 is 2. So this is equal to 2 minus, well, if I plug 0 into this, what do I get? I get 0 squared, which is 0. I get 1. I get 1 to the 4th, which is 1. 1 times an eighth. So I have 2 minus an eighth, or 15 sixteenths. 2 minus an eighth, right? How's that? How's that seem? Okay, Lexi? You agree? Gould, how'd I do? Say it again? Oh, yeah. Sorry. Yeah, 15 eighths. Sorry. You're right. 15 eighths. How could I know if I did it right? Yeah. So Gould was saying, I don't think I know how, or not Gould. Not Gould. Not Gould. I said not Gould. I was just correcting it. Emma. Emma said, I don't think I know how to use the calculator. I'm like, how could you not know how to use the calculator? You literally push menu, calculus, integral, and it looks like what's on the paper.
I figured it out.
I'll fix it. I know what's wrong. This is just an X. And get into the habit, guys, of doing that. Right? I always get into the habit of just taking whatever my integral is and just putting the whole thing in parentheses. Oh, no, it's not going to let me do it. Oh, where is it? Up here? Hang on a minute. I don't know. Let me just do it again. What is it? X squared plus 1? What does that mean? Maybe it doesn't like that. Oh, all right. That's why. Invalid implied multiply. Right? Yeah, it's looking for that. Yeah. Yeah, you can't, I forgot about that. You just can't put a variable in front of parentheses. You have to say to multiply. 1.875. All right. Pretty sweet, right? So there it is. U substitution at its best. So guys, what does that essentially start putting into play? Well, essentially that puts into play the inverse of the trig derivatives, right? So now we have this one right here, which I'm going to say is the same as sine inverse of x, because the derivative of sine inverse of x is this. And this is the same as the one that we just did. And this is the same as that. Now, of course, Evan, I can make this really, really like complicated now by doing what? Not having ones or x's in these positions, but things other than those, which gives us this formula now. Now, here's the thing, guys. If you really think about it, if you remember these three, what does that sort of give you? It gives you the special case, it gives you the one up top, and if you memorize this, then you know the derivative, right? So it's a threefer, okay? It's a threefer. But these are inverse trig integral forms. In other words, if I have to integrate this, right? Something like 1 over the square root of 4 minus 9x squared. Now I have a way to do that. But here's the thing, guys. You just got to memorize it. Can it be done algebraically, Evan? Yeah. Do you know how long it's going to take you to do? Okay? Way too long. Okay? So these are going to be forms that we need to memorize. Okay? So if we look at these 4 different cases, okay? Which case would example 15a bring us to? Is that going to be the inverse of a sine, a tangent, or a secant based on the way that it appears? It looks like a sine, right? Because what do I have? I have 1 on top, I have a square root, I have a perfect square, I have a perfect square, they're being subtracted, right? Fits this form right here. This doesn't fit this because this isn't a square root. Doesn't fit this because there's something in front, right? Get the idea? All right, so In this case, this is going to be my a squared. This is going to be my u squared. Well, guys, if a squared equals 4, then what does a equal? Very good. If u squared equals x squared, then what does u equal? Very good. And so the integral of this must be arcsine of u over a plus c. Now, Brandon, with the set of notes sitting in front of you, that's pretty easy to do, right? Okay, so what does the student sitting in the room say to me? Mr. Ricardo, there's so many cases. There's so much to memorize, right? That's somebody from last year. And I get it because there is a lot, right? There is a lot, okay? Guys, how is B different? How is 15B different? Heaven's looking at the. How is this one different, guys? Yeah, there's an x on top. Now the dx off to the side, this is really the same as that, right? So the dx is in the same position. It's just the x has been replaced, or the 1 has been replaced with an x, right? So here's what we're going to do. In order to do this problem, guys, we got to do a u substitution. Did we have to do one on the last problem? No. Now, if I do a u substitution, it's not that big of a deal. I got to get rid of this x as a substitution, which means this will probably be my u because the derivative of this will have an x in it, right? So you're seeing the logic now, right? All right, so let's call our u this. And so there's my derivative. So there's my x dx, right? And there's my u. So if I'm going to rewrite this, how am I going to rewrite it? It's negative a half of the integral 1 over radical u du. And that becomes a rather easy integral, I hope, because isn't that the same as that, right? So what do I got to do to the power? Add 1. So what's the power going to become? A half, positive a half. Okay, so hang on, I got this. Okay, so my power is going to become positive a half. All right, what do I got to put in front to correct it? Got to put a 2 in front to correct it. Very good. We'll see. All right, if you're not sure, what can I always do? 2 times a half is 1. Subtract 1, and I have u to the negative half, so it works, right? So what is this going to give me? Well, this negative a half and 2 is going to become negative 1. This u to the half is going to become some radical, so it's going to be negative radical. We'll see. Lexi, can you please have a little bit of energy? You're killing me. I want you to be excited about what we're about to do. Fake it, okay? So Lexi, here's the thing. If you look at this problem, what does this most closely match in terms of the inverse function? Does this look like one that would match the sine, the tan, or the secant? It looks like it's going to match the tan. Now, the thing that you're not going to like is the fact that that's not a perfect square, but is that really that big of a deal? No. So this is my a squared, which means my a is radical 2. This is my u squared, which means my u is 3x. And so the integral of this is simply 1 over a arctan of 3x over radical 2 plus c. And should I rationalize that? Well, of course I should, but I'm not going to. 1 over radical 2 is the same as what? Radical 2 over 2, right? 1 over radical 2, same as radical 2 over 2. Lexi, how is D different? Which probably means I'm going to have to do a U sub. All right, so we're seeing the special cases and how they start to pop up, okay? So let's make a U sub. So my U is going to be this. So my DU is going to be this, or that, right? So I feel good about myself because there's my x dx. There's my u. And so this is a pretty easy one because it's the integral, it's 1/18th, the integral of 1 over u du. And we like the integral of 1 over u because it's simply what? The natural log of x, right? What is x? It's 2 plus 9x squared, right? Well, it's this, right? So then I'm going to put my u back in. Bang. Oh, 18, thanks. I think I did it. My pen didn't see it for some reason. Oh, this one too. Maybe that was the one that didn't do it, and then I just copied it. Again, I like these, okay? Guys, notice which one of these did I not do? I didn't do any of these, okay? The reason that I didn't do any of these is because we got to talk about them all on their own. They're a big pain, okay? They're a big pain because the algebra is kind of ugly. Here I have a u squared, but what do they expect to be in front? A u. So do you see how the relationship between these two things has to be consistent? In other words, if this is x squared, what does this have to be? X. If this is 16, what does this have to be? 4. Do you see the problem, right? So if I look at these problems, check it out. Is this going to be okay at the end of the day? Well, it's going to be okay because I have a 9/5, and the 9/5 I can do what with? Bring it out in front. So if I bring it out in front, I get that. And Brandon, am I okay? That's x squared. That's x. Do I have that relationship that I was looking for? I do, right? We'll talk about how to finish it in a minute. What about here? I don't have the relationship that I was looking for, do I? So do you see how we got an issue, right? Do you see how we have an issue? So we're going to talk about how to fix that issue. I'm not going to do it now, though, but we're going to spend time on these problems individually tomorrow.